Hey guys, so before we get started, I wanted to mention that I recorded this whole video with head-mounted, what they call smart glasses. These here, they're made by the company VintageTek, and I just wanted to say that because the video quality is going to be a little different than my normal videos. I did this whole thing after work last night. There was no plan, so the camera was nice because it let me just put it on and do what I'm going to do without really any planning or setting up a tripod or anything like that. But it resulted in a lot more motion than you're used to. So some people might not like the motion since it's on my head, so it's just moving with me. I just wanted to let you know. But I hope you enjoy the video. Today in the lab, we've got a Tektronix 468 oscilloscope. The story with this is I went to buy some vacuum tubes from a guy. He had a whole bunch of them he was getting rid of pretty cheap. In a carrier and all that, and I got there, he had a bunch of other stuff. One of the things he had was this Tech 468. I don't need this for myself, I have tons of scopes, but a buddy of mine was looking for a decent scope, so he told me it worked. He was asking like $30 for it. I didn't even bother powering it on. I just took it. I got home, plugged it in, it actually did work, so I sold it to my buddy, and he gets it and it stopped working after like an hour. He lost the trace on the screen and he was getting error codes when he powered it on. So I ended up buying it back from him, or I traded him something in exchange for it. And here it is. We're going to try getting it going. I've already pulled the cover off and done some basic troubleshooting to get to this point. But let me show you what happens. So when you turn it on, you'll get some funny readings on the digital readout, or for the digital section. So this is upside down, but it's reading code 10. And what would happen is sometimes this would actually pass and it would go into normal operation. You could use these buttons and stuff, but there was never any output on the screen, even like beam find or anything. And if I turn it off and turn it back on, it might give us a different code. Yeah, so this time it's giving us 30. So I've seen 10, 20, and 30. And every once in a while, it'll boot all the way, and you'll be able to use these buttons even though nothing's on the screen. The other thing I noticed is like the LEDs seemed kind of dim. Even the, like if you look here, the LED for the sensitivity per division, it's just dim. Actually, right now when it doesn't boot correctly, they all light up and they're all dim. But if it does boot, they just look dim. So that led me to the power supply. So I pulled the cover off here. Let me see if I can set this meter up. And I don't know if hopefully you'll be able to see it. So on the bottom, these are our power supply test points. So here's our 110 volt. This is regulated. It's only reading 73. Our 5 volt is reading 2.5, so there's something not right there. Our 55 volt is reading only 6 volts, and it's jumping around a bit. And there's a negative 8 volt as well. That's negative 0.6. And I already did this, but if I probe the negative 2450 volts with a high voltage probe, it's only reading about 250 volts, which would probably explain why the screen's not turning on. So I grabbed the manual, and it wanted me to check the unregulated voltages, which are down in this section. And like, so here's our 110 unregulated. I forget the range, but 159, that's high, probably because it's not operating correctly. Our 55 unregulated, it's also a bit high, but it's still not low, so that basically rules out the filter caps and some other stuff. So let me turn this off. So the next section in the manual, I was digging through the service manual. Now I'm trying to do this kind of quick. I'm not necessarily going too deep, but basically, here's the section for the, now I'm suspecting that the 55 volt power supply is getting dragged down because it's the most out of spec out of everything there, and it'll affect the other things. I mean, that's really low. The 5 volt is like 50% off, but this is almost completely dragged down to 0. So I went to the 55 volt troubleshooting section of the manual here and kind of worked my way through. I'm not going to read all this, but I'm just kind of looking around. I'm looking at some of these components, seeing if they're bad. You know, it mentions looking at Q606, which is this transistor here. Tested that out. It's not shorted. There's no burn marks or anything. So ultimately ended up here check for loading by some active device, see isolation procedure. So this is the isolation procedure. And I just kind of looked through these different steps. It talks about, unsoldering different things, disconnecting different things to isolate it to a certain area of the board. So, the first step was unsolder a jumper. Well, I could do that, but let's see if there's anything easier. So step 2 was pull P252 from the interface board. It isolates the vertical output amplifier. So P252 is this guy here. Oh, I need a pair of pliers actually to get that. Where'd I put these? So pull P252. Now I don't know where the vertical output amplifier board is. I'm assuming it's behind this board somewhere, since this kind of goes down and I don't see it connect here. I've never actually taken one of these apart to that level. But anyways, so we disconnected that, and now watch what happens when I turn it on. So not only, you already notice the lights are a lot brighter. The LED, power LED is a lot brighter. And look at that, we have a trace. So there's something wrong with the vertical output amplifier board. So I'm going to have to go through and try to figure out how to at least get to that. I wouldn't be surprised if it was like a shorted tantalum cap, because this thing is loaded with them. So yeah, let's see what we can find. Okay, so I went back to the manual and I was searching around looking for the vertical output amplifier board. And what I found was, it says remove the storage display circuit board using the procedure. So that's up a few pages. Sorry, let me aim this a little. I'm trying this first person view stuff. I hope you like it. It's a little different. So anyways, the storage display circuit board, that's the one that's on the top here. So there's the top, and basically it's pretty straightforward. You just pull out all these coax connectors, the ribbon cables, pull this guy out the back, straight out it says, and then there's some screws. So let's go ahead and do that. I took some pictures ahead of time to make sure that I can put it back together. And probably gonna take another picture, some more close-ups actually, just to make sure. All right, got these guys. So this one pulls straight out, this one up, these two up. I think that's it. So there's all our coax, there's the 2 ribbon cables, there's the 3rd ribbon cable, and the 50 conductor ribbon cable. So now there's 4 Phillips head screws retaining the mounting bracket to the main frame. So that must be these 2. Those actually, it looks like they're all right there. I might need a magnet to pull these up out of here. Okay, the screwdriver's magnetic enough. These other screws just hold the circuit board to the frame. I think this wants this whole frame to come up and out. So now all these cables are still kind of going through there, so we might have to, hopefully we can just set it out of the way, but worst case we can fish them all out. Yeah, I'm gonna fish these cables out, I guess. Bend the coax or anything, the pins. This guy. Oh, there's the vertical board down there in the CRT area. These are kind of a pain because they're bent. Cables are all bent funny. Come on. Alright, hopefully it's easier now that I got one out. Okay, so there's the digital storage board, and I'm going to take this ribbon cable out all the way. Just pulls off these back two connectors. Alright, so it is down in there, and that's the you know, scary parts section. So I'm gonna have to just double check discharging the tube before I take that shield off, and pull that off and see if we can get a better look. I don't know if I see anything. I don't know that I see anything right away. Hopefully there's nothing too major wrong. So, all right, let me double check that this is discharged, and I'll be right back. Here's the board. Let me zoom in a little. You can see there's some resistors, some op amps. There's a larger package op amp there in the middle. I see a Tektronix hybrid chip hiding down in there. I really hope that's not bad. Where is it? I can see it. Sorry, I'm trying to aim this the best I can. It's oh, it's over here under the white trim pot there. Hopefully that's not bad. I don't see anything burnt. There is one tantalum cap there. So what I'm going to do, zoom out a bit. I've got the thermal camera. I'm going to turn this on. I'm not sure how it'll work without the, it might not actually do anything without the digital storage module. I'm going to see if there's anything that is like a hotspot on that board. I reconnected the ribbon cable. So 90 something, that's just a, almost looks like an inductor. I think it's the red thing there that's, oh yeah, 110, 120. So what is that component? I think that's that red thing. Almost, I don't think it's a diode. Oh yeah, so that's pulling. Now, is there anything else? I don't see. Now that could be something downstream that's causing that to get hot. 120 something. Interesting. Okay. Let me look at the manual and see what that is. Alright, so if you remember a moment ago when we had the thermal camera out, I saw this inductor here right below, or right to the red inductor to the right of that connector. It was glowing red hot. So I pulled the schematic up here, and keep in mind nothing else on the board looked even warm on the thermal camera. So here's that section of schematic, and here is, I believe, that connector. Yeah, there we go. So there's our voltages. So there's that inductor. It's a 2.7 microhenry, and then there's a 0.1 microfarad bypass cap there. So I suspected that cap. Now that's a ceramic cap. It's a 0.1 100 volt ceramic cap. I suspected it since nothing else on the board was warm at all. So I thought that cap might have been shorted. So what I did was I pulled the one leg. I didn't pull it out yet. Desoldered the one leg and lifted it. And if you turn this on, you'll see that it operates now, as you would expect. Give it a second. So there we go. We got our two traces. The focus and stuff works better. We can now do the position. Sorry, this camera doesn't seem to be focusing too well on the CRT, which is interesting. But we're back. So I just have that cap out of circuit right now. So what we need to do next is put a new one in. So I'm going to look for a cap that's suitable for that, and I'll solder that in and make sure it still works, then put it back together and test it out. All right, well, I'm kind of surprised. I put the cap on the LCR meter, and it's actually reading okay. It's reading about 92 nanofarads. You know, 0.1 is 100 nanofarads, so I don't quite understand that. I think I'm going to test it on the old Sprague T06 tester with some actual voltage behind it and see how it looks, because it's not making sense. Now, I didn't put a new cap in that position yet, so that'll be interesting if it breaks again. I mean, based on what the circuit is, that doesn't make sense, but yeah, let's test this on the other tool. Okay, so I've got the old Sprague T06 hooked up. I've got it in insulation resistance test mode. That's what you use to test film caps, ceramic caps, mica caps, that sort of thing, instead of DC leakage. That's really only for electrolytic caps. I've got the old cap connected here, and what you do is you hit this white button. You have it on discharge. Hit the white button and you zero the meter at the end, roughly. Okay. And then what you do is you turn the test button on, and you want the meter all the way to the right. So that's the insulation resistance in megohms, and we're on the lower voltage one, which is the 10K scale. So it's off the chart, so that's bad. Now let me do that with a new cap. I'm going to use a 0.1 100 volt film cap. I haven't tested this one yet, but I think I know how it'll behave. Sorry. So go ahead and test it. Now what it'll do is it'll go down, then it'll shoot back up, and it'll eventually settle on the right side of the scale. So so that cap tested okay on the regular LCR meter, but not on a insulation resistance test. So this one is at 1,000 megohms and climbing, 2,000 megohms, 4,000 megohms. It'll just keep going. 10,000 megohms. So there's definitely something wrong with that old ceramic cap. I have a feeling once I get this cap installed, the scope will continue to work correctly, but we will see in a few minutes. All right, well, the new capacitor is installed. I did kind of a sloppy job with it because I did not remove the vertical output board. I just did it in place. It was kind of difficult to get the soldering iron down in there, and I think there was a thick ground plane down one of the leads, the top one. So actually not ground plane, but yeah, there's just some thick copper there. It's hard to heat it up. So anyways, let's plug the connector back in here, and okay, that's good. Get this turned back on. Well, the scale illumination lit up. That's a good sign because that wasn't lighting up when the power supply was dragged down. So look at that. Let's get the focus. Move left and right. We got two traces. I would say that's fixed. So yeah, that cap was bad. It had bad insulation resistance, so it was leaking all the current to ground. All right, let's get the top back on and close this thing up. All right, well, I've got the storage board put back on. It's all reconnected, so we're going to go ahead and fire this up and see what happens. So there's nothing on the display, which is good. When it boots up correctly, you don't see anything. Okay, so there's our trace for channel 1. There's our trace for channel 2. The lights are nice and bright. Let me connect a signal up to it and see what happens. So I've got the 3325B with a 1 kilohertz sine wave at 1 volt peak to peak, and it's terminated into 50 ohms. All right, there's our sine wave. So yeah, the scope seems to be working fairly well. That's about right for 1 volt peak to peak at half a volt a division. Let's try channel 2. Set that also to 0.5. Okay, that looks good as well. Intensity is good. Let's try digital. I don't know too much about the digital features, but I know that's working. And we can set up our cursor here for volts. So let's see here. This is kind of finicky. Okay. So there's our about 1 volt peak to peak. So that's working. So I'd say we fixed it. I just got to put this knob back on. I actually stole this to use on a Tektronix 576 that was missing one, but it doesn't quite work there. So I'll put this back together and it'll be complete. Now the other thing that I did with this before really troubleshooting it, when my buddy was explaining the issues to me, I thought it might have been the ROM rod issue with these MOSTEK, what are they? MK 36000 series. It's a pretty well-known issue on these scopes. they lose the contents of the ROM. And here's the other one. I think one of them's ROM and one of them's flash. I forget exactly how it works. So what I did was I bought the VintageTek Museum replacement ROM. It's actually on an adapter board. I'll show you in a minute because I'm going to take it out and put these back in since these weren't the problem, and I'll just keep that. It also has a service ROM built into it, which is kind of cool in case I ever need to troubleshoot it further in the future. So let me show you how to get to that. Okay, so on the back of the scope, there's a 4 screws up here you take off after taking the cover off and all that. And there's a screw here, and there's a screw on the same spot on the other side. Take out. Where is it? There it is. Okay, and then you need to remove this ribbon cable. And just pull it up and out. You might need something to help the back part up with. What was I using earlier? I had another tool here. I'm using the turning this down a little. Chip lifter tool. Come on. Okay, so once that's out, you can kind of work this out. It's kind of tricky, but okay, so kind of go pull out the right side first. Then you can flip this up. Be careful, this power connector here might come out, so you might need to check that. Anyways, here's the VintageTek ROM. And there's 2 sockets here, but this only takes 1. And then this jumper here, it's flying lead, it goes over to the pin 20 on the second socket. It's the chip enable pin. Let's take this out. So there, you can see that's in pin 20 there. Pull that out. And then what I need to do is I need to look at my phone and figure out the orientation of these chips. Okay, so the first one goes in like this. Okay, and then the second one goes in like this. All right, so those are in correctly. So now we can put this back. Actually, notice this popped out, so make sure you check these coax cables. Okay, and the power cable. Let me get this back down. This, like I said, is kind of finicky. You kind of gotta. So here's that power cable. Kind of work the right side in. Oh, I'm not quite sure. Just kind of jiggle it around until it goes back in. Hope you guys don't mind the first person view. It makes videos a lot easier for me where I normally might not release one. So I know for some people it might bother with all the motion, but all right, so there's that. Let's get these screws back in. What I found for this second screw is sometimes it helps to, oh, let's see, why is it, okay, just gonna kind of lift up on the frame. Anyways, that's good enough. I think let's connect the ribbon cable back up. And let's turn it on and make sure it boots. Oh, help if I plug the power cable back in. Turn right on. And since the display lit up this time, since I already had it enabled from before, and it's, I think we're good, but let me plug the signal cable back in. Go back to 1. Oh yeah, that's a nice bright display. And yeah, that's just about perfect. So yeah, we fixed it, and it wasn't the ROM. Just one bad ceramic cap. Who would have guessed? I hope you guys enjoyed the video. As you can see from the mess down here, I've been playing around with all sorts of different stuff. Came across some calibration gear recently. I've got a Fluke 5440B DC calibrator. I got a Valhalla Scientific 2724A resistance standard. Ended up paying like $180 total for all this stuff. I thought the Valhalla was going to be no good because it was missing the top cover, but it works perfectly fine. So happy about that. There's a Fluke 5200A over there. I've got the Fluke 5205A to go with the 5200A. This one's broken. I'm trying to make a video on it, but it's giving me a hard time. Definitely difficult to troubleshoot. The other thing I've got in process, that's what most of this stuff is the German row test tube tester. So this is the main board for that. Here's the top plate. So I'm pretty happy about that. It's pretty much the best tube tester ever made as far as I know. And that is what all this junk on this table is. These are all the relay boards. I've been just soldering all this together. Basically a big kit. You just solder everything together. It's a little more difficult than a regular kit, like a Heath kit or something. And there's some small surface mount parts, but it's coming. So I'll do a video on that when it's ready. So I hope you guys enjoyed the video. I thought that was pretty cool. So thanks for watching.